Domain of functions. We are given a function f of x is 3 over x minus 7. We need to find the domain of this function. In this case, this is a rational function. So the domain will be straightforward, where x should not be 7, because when x is 7, then you get 3 over 0, which is undefined. The function is not defined at x equals 7. So in the domain, you exclude 7. And let me show you how to write the domain using interval notation. So we show it like x minus 7 not equals 0. That means x cannot be 7. And it is very obvious. You can understand. Now on the real line, we start on the far left, negative infinity, and far right will be positive infinity. And then we want to exclude 7 from the domain. So then if you use the interval notation, you will write negative infinity to 7 and then connect with union symbol 7 to infinity. So this is the domain for the function f of x, which is 3 over x minus 7. We are taking second example where your function is gx and equals 7 over x minus 5. So just like number 1, in this case you will say that your domain will exclude 5. Now we write the domain of gx using interval notation and also show you on the real line. So clearly you see the domain of gx will be negative infinity to 5 and then 5 to infinity. Now we want to see what will be the domain of when I add these two functions, we subtract one from another, and then we multiply also together. This will be just the common domain. Now look at this structure here. So both the cases, it starts negative infinity, goes up to 5, and then there is a break on 5, and then 5 goes again break on 7, and then from 7 to infinity. So we'll be writing our domain exactly what we said. We'll take example 4. We have f of x is 3 over x minus 7. The domain is negative infinity to 7 and then 7 to infinity. Gx is 7 over x minus 5. So the domain is negative infinity to 5 and 5 to infinity. And remember, the common domain is negative infinity to 5, then 5 to 7, and then 7 to infinity. You have seen in the previous example. Now we are looking for domain of f divided by z. So f divided by z function is like this. When you say f divided by z, you can write like this, f over z. So your f function is 3 over x minus 7, and your g function is 7 divided by x minus 5. You may do some simplification, and in the simplification then you will see that it comes out like 3x minus 5 and then 7x minus 7. Then you may think that in the domain I just need to put x not equal 7. That's not enough, because when you are doing operation on functions, you must check the common domain. So the common domain we said already, negative infinity to 5, then 5 to 7, then 7 to infinity. Negative infinity to 5, and then 5 to 7, and then 7 to infinity. Remember this one. I'll give you another example. You'll see how it is changing. I'm taking example 5. In this case, my function f of x is 3 over x minus 7 and gx is 7x over x minus 5. So both the cases now, you see the domain will be, for the first one, negative infinity to 7, 7 to infinity, and the second one, negative infinity to 5, 5 to infinity. This x doesn't make any problem on gx. But see what happens when I'm taking f over z. So f over z, your f function is 3 over x minus 7, and g function is in the denominator, so you can flip it, write x minus 5 over 7x, or the way we have seen in example 4 you may follow. So then finally see that it comes out like 3 x minus 5 over 7x times x minus 7. Now it is interesting. Look at the domain now. 7 is already excluded in the domain, but I have a new term here, 7x. That one is telling me that I cannot have x equals 0 either. So then my domain is now excluding following things. You can see you have negative infinity, you have positive infinity. You have seen already 5 is excluded, 7 is excluded, additionally 0 is excluded. So my domain for this one will be negative infinity to 0, then 0 to 5, then it goes 5 to 7, and then it goes 7 to infinity.